the world's most advanced cranes, the largest steel truss girders ever lifted, and a bridge so massive it cut an 80-minute trip down to just 20. This is China's newest engineering shock to the world, the Changtai Yangtze River Bridge, a record-breaking marvel that redefines what a bridge can be. This structure is not just another mega project, it is the first bridge on the Yangtze River to fuse three transport systems into a single artery of steel and concrete: an expressway for high-speed vehicles, a regular road for daily commuters, and a 200 km per hour intercity railway, all stretched across 10.3 kilometers of turbulent water. The achievement is unprecedented in scale and complexity. The challenge of spanning the Yangtze has haunted engineers for generations, a river so vast and unpredictable that for centuries it stood as both a lifeline and a barrier. By the early 21st century, the Yangtze River Delta had transformed into one of the busiest economic hubs on the planet, but traffic between Changzhou and Taizhou was strangled by long journeys and bottlenecks. An 80-minute crossing was draining productivity and slowing growth in one of China's most vital regions. The answer arrived in the form of the Changtai Yangtze River Bridge, a design so ambitious it demanded rewriting the rules of modern bridge engineering. The heart of the project is a main span of 1,208 meters, longer than three Eiffel Towers laid end to end. This instantly shattered global records, surpassing Russia's Russky Bridge and China's Sutong Bridge. Yet the true breakthrough lies not just in length but in function. The lower deck became the stage for a radical innovation. Instead of placing the railway at the center with roads on either side, engineers dared to push the railway to one side and the local road to the other, creating an asymmetrical design never attempted at this scale. The result was a structure that carried its loads like a barbell, weighted unevenly. Every cable, every truss, and every joint had to be calibrated to keep the bridge balanced against the constant forces of trains, cars, wind, and temperature shifts. The towers that hold this behemoth rise 350 meters into the sky, diamond-shaped, gleaming, and designed as steel-concrete composites. These pylons merge the brute strength of concrete with the resilience of steel, capable of flexing under seismic shocks and temperature swings while holding the immense weight of deck and cables. Each one stands as tall as a 120-story skyscraper, visible for miles across the Yangtze Plain. Beneath the waterline, the foundation work became a battle against nature. The Yangtze's riverbed of shifting silty clay and powerful currents defied conventional techniques. Engineers deployed some of the largest open caissons in history, colossal hollow chambers sunk into the mud under their own weight. When resistance grew too high, custom excavation and jetting methods were developed to cut through the clay with speed and precision. The sinking speed achieved by these caissons set a world record, an achievement recognized in the global engineering community. With foundations locked and towers rising, the next hurdle was lifting the heaviest steel truss girders ever fabricated. Each segment weighed thousands of tons, as large as naval vessels, and had to be positioned with flawless accuracy hundreds of meters above the water. Ordinary cranes could not accomplish the task. The project required machines as groundbreaking as the bridge itself. The solution was the creation of next-generation mega cranes. Among them, the Zoomlion W 12,450, the world's first tower crane exceeding 10,000 ton-meters of lifting capacity. Combined with massive deck cranes, this system allowed segments to be hoisted and placed with millimeter-level precision. Reports describe these machines as guided by satellite-linked systems, providing real-time corrections to ensure alignment under wind and current. For the first time in history, bridge construction fused industrial machinery with space-age navigation. The results were astonishing. Ultra-heavy segments were set down perfectly, one after another, until the truss stretched unbroken across the Yangtze. The precision of these operations shocked veteran engineers, cutting years off the project timeline and proving that construction at this scale could be industrialized rather than improvised. What emerged was more than a record-setting bridge. It became a living laboratory for the future of infrastructure. The technologies pioneered here, steel concrete composite pylons, asymmetric multi-deck layouts, mega cranes with satellite precision, are not confined to the Yangtze. They can now be adapted to offshore wind farms, deep water ports, and even the launch towers of future spaceports. The Changtai Bridge demonstrated that building at the frontier of size and complexity is no longer beyond human reach. This project also stands as the culmination of decades of Chinese bridge engineering. The Sutong Bridge, the Husutong Bridge, and other Yangtze crossings served as stepping stones, each pushing the limits further. Changtai represents the bold leap where lessons, risks, and innovations converged into a single masterpiece. It is the ultimate expression of how infrastructure in China has evolved from ambitious to audacious. The strategic significance cannot be overstated. Cutting travel time between Changzhou and Taizhou from 80 minutes to just 20 transforms daily life for commuters, businesses, and logistics. The economic ripple effect across the Yangtze Delta will unfold for decades. Every container, every passenger, every delivery that flows across this bridge adds momentum to one of the world's busiest industrial zones. It is a steel backbone powering the next chapter of regional growth. Beyond economics, the bridge is a symbol of national pride and global influence. Infrastructure is geopolitics, and every record set on the Yangtze reinforces China's standing as a leader in engineering. The message is unmistakable. The ability to design, fund, and complete the world's most complex bridges is also the ability to shape trade, connectivity, and the very map of globalization. At the human level, the bridge carries stories of determination and sacrifice. Thousands of engineers and workers endured long shifts, dangerous conditions, and relentless challenges to see it completed. Their work turned blueprints into reality, steel into arteries of commerce, pylons into monuments that will outlast lifetimes. Every vehicle and train that crosses is a silent tribute to their dedication. Now, standing finished, the Changtai Yangtze River Bridge holds not just records but a vision of the future. It shows that the boundaries of engineering are still expanding, that new materials, machines, and designs can bend nature to human will, and that one structure can reshape the destiny of entire regions. This is more than a bridge, it is the embodiment of a new era, where satellites guide cranes, where steel and concrete merge into hybrid giants, and where infrastructure becomes the backbone of civilization's next leap forward. And that is the story of how China opened the world's longest cable-stayed bridge, built with technology never seen before, transforming not just transportation, but the very possibilities of modern engineering. Don't forget to like, subscribe, and comment your thoughts below, because on this channel, we bring you the future of science, technology, and innovation.